General Mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we're going to be looking at Euclidean Geometry, Part 2. That is your grade 12 Euclidean Geometry in Technical Maths. The geometry that we're going to be doing today will be based on proportionality and similarity. We've done the ratios and similarities in the lower grades, the previous grades, but let's look at what should we know at the end of this lesson. By the end of this lesson, we should be able to interpret. In other words, we are not going to prove anything. So we're just going to interpret and apply the following theorems. The theorems that are here are that a line drawn parallel to one side of a triangle. So which means you'll be having a triangle and there's a line that is drawn which is going to be parallel to the other side of the triangle. So they say it divides the other two sides proportionally. So which means that it will divide this side over there, it will be the same as this side over there. That is all that we need to know for now. At the end of this lesson, we should be able to know that the equiangular triangles, equiangular. So the word describes itself. Equiangular meaning that there are equal angles. So they are similar, right? The equiangular triangles are similar. So in other words, if the two angles, they are not equal in size, but when the two triangles are not equal in size, but the angles are the same, they are equiangular. So therefore, those two triangles will be similar. When we do similarity, on the slide on the similarity, I'll also explain it further. That the triangles with sides that are in proportion are similar. So in other words, you can see that there, if we have sides that are in the same proportion, therefore the two triangles will also be similar. All right, so those are the three theorems that we're going to be looking at. There's two theorems, but these two here, it's one theorem because they talk to similarity, and this one talks to proportionality. We'll also put in the midpoint theorem, just one activity on midpoint theorem, so that you don't confuse the midpoint theorem and the proportionality theorem. The midpoint theorem is the one that was done in grade 10. All right. Now, let's look at the pre-knowledge on the ratios. Now, when we have the ratios, so remember in grade 9, I think that's where you do your ratios. So if two or more ratios are equal to each other, then we say they are in the same proportion. So we're going to use this terminology a lot today. So they will be in the same proportion. So proportionality describes equality of the ratios. So if the ratios are the same, are equal, therefore the two sides of the ratios are equal, then we say they are in the same proportion. So let's look at the two diagrams there. If I look at that length there, it is A. That length there is B. So in other words, if I take A over B as my proportion, so A over B, then I'll say that is equal to C over D. So you can see C over D, then A and B are in the same proportion. So you can look at this, the A and the B are in the same proportion because I said A over B, so they're in the same proportion. C and D are also in the same proportion. So we're saying these two ratios, because this one is equal to that, therefore they are in the same proportion. So if they are in the same proportion, we can then play around with them. can play around with them. I can say A over C is the same as B over D. So I can play around with this. So in the next slide, you'll see how we play around with this. Now, look at this. Now I'm having a line. So remember, we also need to know this theorem in words, because you can be asked this question that you must complete the theorem. A line parallel to one side of a triangle divides the other two sides, and that can be missing. Then you'll have to write down proportionality. So a line parallel to one side of a triangle divides the other two sides in the same proportion or proportionality. Agreed. Okay. So in this triangle RQS. So in this triangle, you can see TU, it's parallel to QS. These two lines are parallel. So what does this theorem say? It says, if this line here is parallel to the other side there, it divides this other two sides. You see, the two sides that are left will be this one. This other side is parallel to that. So I'm left with those two sides that I'm going to work with. So the first one says RT over TQ. So RT over TQ will be the same as in the same proportion, remember. So it must be RU over US. So that is in the same proportion. So only if that line is parallel to that will this apply. That's how we do the theorems. So only if this over that will this applies that these lines are parallel. Correct. The other one will be RQ. So if I start here and say RQ, then I take TQ. So on the other side, I must do the same. I must take RS over US. Okay, so it must be in the same proportion. So we cannot say RQ over TS is the same as RU over US. That will not be, you will not be working on the theorem. Now the next one there, it's RQ. So if I say RQ over RT, I must do the same on the right hand side. So it must be RS over RU. That is the ratio. So they must be in the same proportion. So any other proportion, I can work on any other proportion on that one. I can start this side, I can say RT over RU will be the same as TQ over US. So you can play around with it, but they must be in the same proportion. Okay. Don't worry about this one and that one. We'll talk about it when we do the similarities. All right. Let's look at activity number 1. Now, in activity number 1, in triangle ABC, so given triangle ABC, now you're given that this line here, which is DE, it's parallel to BC. So those lines are parallel. So I can play around with my ratios and all that. So, but now you are given that AE is 15 units. 15 units. EC is 6 units. So we must put all those units together. DB is given as 4 units. I don't have the length of AD. So I can play around with this. I can do as many proportions as I like. So I can say AD over the whole of AB equals to AE over the whole of AC. But that won't help me. So I need something that will help me here. So this should be the easiest of them all here, because it is a direct one that we have talked about in the previous slide. So if you check this, that will be the first one, that AD over BD, and you see, AD over BD. So I'm going to write it down. AD over BD, it's equals to, and you see there they said with reason, right? AE over EC. C is in the same proportion. I said this over that will be the same as that over that. So it must be in the same proportion. So it must be AE over EC. What is the reason here? Now, the reason is that theorem, line parallel to one side of it. But I cannot write the whole sentence in there. So it's either I can write proportionality, or I can write line parallel to one side. One side. But if I choose to write this one, then I must write down the lines that are parallel. DE, it's parallel to BC. So if I choose to write that second one, that means that I must write down the lines that are parallel. Because you might find that in one sketch, you'll have so many parallel lines there, so you must state the lines that we're talking about. You might find that we've got two sets of parallel lines, then you need to elaborate to say, okay, now this is the lines that I'm talking about. So that is why that is very, very, very important. If you just stop here, you're not going to get any mark. So please make sure that you write down the full, the set of parallel lines that are, the set of lines that are parallel. If you write proportionality, that is fine. So you just leave it like that. Then you leave it, you get full marks. You don't need to write parallel lines there. Right, now, in this case now, I then substitute. I'm going to substitute the value of AD. Oh, AD, there's nothing in AD. Because that is what I need to find, the length of AD. Now remember, this is the length that we're talking about here. Now, BD, it's given as 4 units. AE is given as 15 units. EC is given as 6 units. Then I cross multiply. Need to solve for AD then. So I'll say AD multiplied by 6 equals to 4 multiplied by 15. Right? So for me to get AD, then I'll have AD will be equals to 4 times 15, it's 60, divided by 6. Then from there, how am I going to get the value of D there? AD, so therefore AD will be 60 divided by 6, which is 10 units. If it's given as units, write it as units. If it's given as centimeters, write this as centimeters. Okay, so that you don't lose marks in terms of units. Okay, so that's an easier question there, which is straightforward. Looking for the length of AD. The length of AD will go this over that, or this over that. Another way of doing that will be, I can go AD over this and AC over this one. But the challenge here will be, I'll have this one and that one adding the two unknowns here. So let's say this is an X, so that will be, for the whole of AB will be 4 plus X. 4 plus X. But you can still do it, because then you'll have to transpose and do what? But that will be a very, very long way of doing that. But you still be correct. Okay, you still get the answer to 10 minutes. All right. But in this question here, This is a lovely one also. Now it says, in this triangle again, ABC is given. But now, what do we have? Now we have the DE is parallel to that still. Now, AD is now given as 9 units. AE is given as 12 units. And then EC is given as 4 units. Okay. Now, the question here now says you must get the length of AB. I need to get the length of AB. So how am I going to get AB? Now, first of all, the two lengths on the other side are given, so I know that that length of that will be 16. The whole length, 12 plus 4, that will be 16. So I'm fine with it. But the whole length here, I don't know it. I don't know what is the whole length here. I even don't know what is the length of this one, of AD, of BD. So how am I going to write down my ratio? If I go this 1 over that equals to this over that, I'm not going to get 9 over this, but I'm not going to get AB, you see? So it's either I can do it this way, I can still do it that way and get the length of that line BD, then I can add it to 9 to get the length of AB. But the easy one to do will be, because I need AB, why don't I put AB there? Start with AB. Because AB over AD, this side I have AC. I don't have a problem. I'll do it over AE. So I'll say the whole of AB over that small side there, which is 9, which is 18. The same way I've done on the left-hand side, I must do it on the right-hand side, which is going to be AC. You see, on the other side, I said AB over AD. That side, I must say AC over AE. So I'll say AC over AE. Same applies. Let's write down the line parallel to one side of a triangle. Then from there I can write parallel lines DE parallel to BC. Okay, you see I'm using this one because I want you to get used to it that we must write parallel lines there. So then I can substitute the value of AB, I don't have. The value of AD I have, which is 9. The value of AC, now you can see AC is not given, but I know what is AE plus EC. The two form part of AE. So which is going to be put 12 plus 4, which is 16. AE is 12. Then I'm going to get the value of AB, which will be the same as cross multiply that. I'll get 9 times 16, and I'm going to divide this by 12. Now I must get the length of AB. So the length of AB there, I think it will be 12 units. Because 3 there goes 3 times, 3 there goes 4 times, 4 there goes once, 4 there goes 4 times, 3 times 4 is 12 units. So the whole length of AB will be 12 units. What if they ask us now to find the length of BD? So the length of BD there will be 12 minus a 9. So the length of BD there will be 3 units. So if I check 9 over 3 must be the same as 12 over 4. 9 divided by 3 is 3. 12 divided by 4 is 3. So they're in the same proportion. That's what we're talking about. Okay. So if I go 12 over 9 must be the same as 16 over 2, which must be the same in the same proportion. All right. Now, activity 3, very, very, very important question in here. In activity 3, now the difference with the activity that we've done in the previous slide and this one is that the other ones, the lengths were given. In this one, the lengths are not given, but we are given the ratios. So which means, you can see in the note there, let me first read the question. In triangle ABC, AB is parallel to FD. So AB can see that is denoted by 1 there, so that one is 1 there, so therefore we have 2 of these in that and the other ones. Ne? You see those arcs there, ne? Right. So now AF parallel to DE, I've indicated that. FE is to EC, it's 3:4. It's very important that you know how to write this one also in a fraction form. So in a fraction form, that will be FE over EC, it's 3/4. Now, determine EC is to BC. So this one can also be written as EC over BF. Now, here's the note, very important. 3:4 does not mean that the length of FE is 3. It does not also mean that the length of EC is 4. So it means for any A, we can then say that FE is 3 times that A. Okay. For any EC, it will be 4 times that A. So for every 3A in FE, for every 3 of A in FE, there's 4 in EC. And that is what it means. So that is why most of the time you see your teachers writing 3K, 3A, 3B, and all that. So that is not a length. It is not given as 3 units or 3 centimeters or 3 meters. So those are not lengths, but it's a ratio. It's a ratio. So now, but we need to write it down there. So I'm going to say FE, where's FE? Our FE there, it's 3. I'm just going to write this 3K. Right. And we also have EC. EC is 4. So I'm also going to write 4K. Right. So if you look here, we are looking for EC, EC, and BF. But BF we don't have. See? So we're looking for that ratio of BF and EC. Now, what is the first thing that I need to do? I need to look at the parallel lines. I have these parallel lines here, and that parallel lines here, and they are in this triangle, if you can check. They are in this triangle. So I can, and this is where I've got my 3K and 4K. So what can I do here, because I have that in the triangle? I see I've got FE over EC will be the same as what in the triangle that I've written, AFC. So this side over that side will be the same as AD over DC. All right. If I take, for instance, BF, remember, and I will need BF in that case. So if I take BF, BF will be in which triangle? In this triangle where these lines are parallel. Can you see there? In this triangle here. I'm just going to do it like this. Mess it up like this. Now, in this triangle here, in the bigger triangle, which lines are parallel? This line is parallel to that line. So what would be the ratio? If this line is parallel to that line, what would be the ratio? My ratio will be BF over FC. And you see, it's equals to AG over DC. But already I know that this is 3A and that will be 4A. How do I know that? Because in the smaller triangle, this over that will be the same as this over that. I'm just writing them as 4a and 3a and 3k and that. Okay, I can just put this 3k and 3k there. Okay, doesn't matter. Right, so that ratio here will be the same as this ratio there. Then in the bigger triangle, this ratio here to the parallel lines is the same, that ratio over that will be the same as this over that. So I'm going to write it down so that then we're not getting confused with the sketch. BF over FC will be equals to, so I've got BF over FC, you see in the bigger triangle. So now I'm going to that side. So it will be 3 over 4, right? So it will be 3 over 4. I can write 3k over 4k, but the k's will cancel out. But remember, what is FC? FC is 3k and 4k. So which means FC in total, the total length of FC will be 7. So I'm going to go BF over 7, it's equals to 3 over 4. So I can cross multiply now. So I'll have BF will be equals to 3 times 7 is 21 all over 4. So now I know what is my EC. I know what is EC. EC is 4. I want to write it as and BF there. So I write down the answer. So my EC is 4, that was given. So I'm going to write 4. But my BF is 21 over 4. Right, so that is the ratio that they're looking for. EC is to BC will be 4 is to 21 over 4. Now, I don't want to write this ratio in that form. This ratio can be the same as, remember if I write it, for instance, let me write it there, just create a space there. If I write it as EF, EC over BF, I'll have 4 over 21 over 4. Agreed? Now, I don't want it to be written like that. What can I do? I'll have 4 multiplied by 4 over 21. Remember, when you multiply, when you divide, then you turn the denominator upside down. So therefore, you're going to have 4 over 21. So therefore, 4 times 4 is 16, and that is over 21. So this ratio can be written as 16 is to 21. All right. I should have multiplied 4 by 4. 4 times 4 is 16, then I don't put the 4 as a denominator for 21. So that will be the ratio for this. So these are the type of questions that are asked in an exam, whereby, and these are not, as I say, these are not the lengths. Sometimes you'll be given that ratio and you're given the length. Then how do you find the length? And that's a question of ratios, whereby you say, if I've got 20 rand, in grade 9, if I've got 20 rand and it's divided into a ratio of 3:4. So remember, it will be 3 over 7. We add the 3 plus 4, we get a 7 total. 3 over 7 multiplied by 20. And that's how we get maybe the ratio for 3 and the other ratio for 4. Or the answer for 3 and the answer for 4. Right. So this is, as I say, the way in which the exam is being asked. Okay. So the ratio and proportion is not a very challenging thing. We need to get full marks in this question, as long as we can see which parallel lines you are using. You see, with these ones, the parallel lines that we're using AB, it's parallel to DF. Okay, because it's BF over ECFC equals to AD over DC. So we're using those parallel lines. But for us to get 3 over 4, for that other one, we've used AF and DE as parallel lines. So it is very important that you check which parallel lines you have used in which triangle, shade your triangles, then so that then you will see. This one is the one that I'm going to use for which ratios. All right. So you see, in this triangle, I cannot use BF because that triangle here does not have BF. So the whole triangle here, ABC, will have BF. So that's what I'm talking about. All right. Now there is what we call a converse of the theorem, of the proportionality theorem. What does it say? Now it says, if the line divides the other two sides proportionally, so in other words, if you are given that RT over TQ is equals to RU over US, and that is given, which means that this line here will be parallel to that. So once I can prove that this line over that is the same as this line over that, therefore I can just say these lines are parallel. Just the opposite of the other one. So which means, if for instance I've got a 12 here, and a 6 or a 3, let me say 2, then this side I've got that's 6, so this one I've got an 18 and a 3, for instance. So if I take 12 over 2 equals to 18 over 3, that gives me 6 equals 6. Therefore, I can then say this line here, TU, it's parallel to QS. That's my conclusion, because I've already seen that the ratios are in the same proportion. So therefore, so this is what it's this statement it's saying. RT over TQ, RU over E. Therefore, then TU and QS are parallel. So you might be asked this question whereby it says the two sides are in the same proportion. Are these two lines parallel? Yes, they are. But if I got another number there, say I've got a 9, a 6 here, and I get a 3 there, so which means that those two lines cannot be parallel because their sides are not in the same proportion. All right. This is just the same thing here, RQ over TQ. So if I take RT over TQ and RS, also RQ over TQ and RS over US. So that will be in the same proportion. If those ones are in the same proportion, then we're saying TU, it's parallel to QS. All right. Just to quickly check with this one, use the given side length of triangle ABC, of triangle ABC, ABC, to determine if DE is parallel to BC. So that is the activity that I did in the previous slide. So what do you do here? Oh, I'm just going to be, innovative a bit. I want us to look at AC over AD. It must be equals to, I said, AC over AD. Right? So that side, what should I say? BC over EB. BC over EB. Right. You can do it the easy way. So the easy way will be CD over AD is this over that. I just want to check quickly. AC is how much? AC is 24. How did I get it? 16 plus 8. AD is 8. BC is 18. And EB is 6. 24 divided by 8 is 3. 18 divided by 6 is 3. Therefore, if they are in the same proportion, what do I write? Therefore, DE will be parallel to BC. You see, it's not given there that these lines are parallel. So if I can just check this 2. 16 over 8 is 2. 12 over 6 is 2. They're in the same proportion. So therefore, the 2 will be in the same proportion. If they're in the same proportion, therefore, we're going to say that the 2 lines are going to be parallel. Right. Now let's look at this one. In this question, I've just removed some of the questions there, but there are just 3 questions that we need to do there. The diagram below shows the circle DGF. You see, there's a circle here, DGF circle. O is the center, like it when O is the center, it's easy. Having a radius of 6 units, so meaning that this line here is a radius, it's 6 units. This line here is a radius, it's 6 units. This line here is a radius, it's 6 units, right? So now, they say BGC is a tangent, so in other words, it's touching that circle at only one point. OG and DF, they intersect at E, right? Such that OG is perpendicular, so that angle is 90. What do I know about this theorem? This theorem number 1 in grade 11. This line here will be equal to that line here. All right? Now, no problem with that. Now, you are now given, you see now here you're given the ratio again, you're not given the units. Right. Show that, so I'm just going to write it like this, OD over OB is equals to 3 over 5. Now show with reason that DF, this line here, show that it's parallel to this line there. How do we show that those 2 lines are parallel? In this case, I only have this length and that length. I don't have this length here and that length. I would have used that. But now let's check what is given here. I'm given that OD over OB. So OD over OB is 3:1. So I'm going to write 3K and 5K. But this length here, I know it's 6. All right. Now, show that DF is parallel to BC. How can I show that this is parallel? That's quite very easy. That should be 1 mark actually. Why I'm saying it's 1 mark it is because this angle here is given as 90 degrees. I know that the line, the radius and the tangent are perpendicular at the point of contact, which means that that one will be 90. So angle OGC. So I can write there angle OGC. OGC is equals to 90 degrees. What is the reason? Tan perpendicular to the radius. The theorem in grade 11. Now, if this angle and that angle are equal, you see that one is above there, this one is above the line here. What can we say these 2 angles are? They are not alternating, but they are corresponding angles. So those 2 angles will be corresponding angles. So which means that that angle here at E, angle OEF, and angle OGC will be equal, and they're both equals to 90 degrees. And these angles are corresponding. If the angles are corresponding and they're equal, Therefore, it means that the line DF will now be parallel to the line BC. Those two lines will be parallel because those two sides are going to be in the same proportion. Right, so those two lines here will be parallel. It is because of the corresponding angles which are there. So we got the corresponding angles which are there. Okay. All right. Now we get the point here. Now, the next question here says, determine the ratio of BC is to DF. Now we need a ratio. We need a ratio of that. Now, first of all, for me to get the ratio of that, what should I do? I can then first get the two triangles to be similar, right? Two triangles to be similar. Because triangle ODF, if these lines are parallel, as we have proved in the other one, it means that this angle here will be equal to that angle there. And this angle here will be equal to that angle there. The corresponding angles. And this angle here will be a common angle, bringing in the similarity. All right. So if this angle is a common angle and that angle is equal to that and this angle is equal to that, the two triangles are similar. So if the two triangles are similar, I can write down I can write it down there, but let me first write down the ratios. The ratios, I think it was 3K and 5K. Right. Now, I need the ratio there. Remember, I need the ratio. So for me to get the ratio of this, I need to get this part here, right, over this part. Or let me write down the similarity first. So the similarity will be triangle ODF. It's similar to triangle OEC. OEC. Right? And the reason for similarity there is angle. Right. Now, from the similarity, I can write down the ratios. So remember, in the ratios, the angle O is equal to angle O, that's the angle that we're talking about. Angle D is equal to angle E, those two. Angle F equals to angle C, those two. So let me write down the ratios. So I can say OD over OE OD over OE, yes. Then that will be OF over OC. Then I can write down another one, DF over EC. Fine. DF over EC. Okay. So now what am I looking for here now? I'm now looking for, you can see OE. Did I have OE? No, I cannot have OE there. Let me see there. Right, this line here, we said it's equal to that line here. Right? So if I go OD over OE, right? So that's OE there. So here, I don't think it's an E there, so we need to take that one out. So it's OD over OE, right? And we've got OF over OC. Then we're going to have DF over EC. Okay, so now how am I going to write down BC? Oh, this is B, sorry, this is B. This is B, so this, why did I write OE here? So it's OB sorry. OBC, my mistake there. So that should be OBC. So this should be OB and that should be BC. Sorry, my mistake there. Right. Now, so this is E. Sorry. Right. So OD over OB. So which one am I looking for? I'm looking for DF and BC. But what do I know about the other ratios? So this 3 over 8 will be the same as DF over BC, right? So now that should be 3K over 8K, because that whole length, that ratio of that is 3 and that one is 5. So if I can just quickly go back and check that question, right? So that's 3 and 5, yes. So it's 3 and 5. So it's 3 and 5. So if I take that part over that, it will be the same as this one over that. So that one is 3K over 8K, and the answer there will be 3 over 8. So I can write it properly. BC is to DF. So my BC is 8, and my DF will be 3. So that ratio will be 8:5. Okay. Right. Now, that question there, I've removed that question, the numerical value of that, because we still need to calculate some of the sizes, which I did not put in there. So now determine the ratio of EG to OG. So EG, so this is 3K, and that is 5K. Right, EG is to 5, so EG and OG. Right. So EG, the ratio of EG to OG, because OG, remember this line here, it's 6. Now, how am I going to get the ratio of EG from this? Right? So I'm going to get the ratio of that. So now, remember this is the length. Okay. So if I need the length of that, how am I going to get it? If I need the length of that, how am I going to get it? This is 6. Remember this is 6 units. Then I need, this is 6 units. Right? So the length of EG over OG will be equals to 2 over 5. Right? That is the length of OG will be that 2 over 5. So it will be 2K over 5K, and the K's will cancel out. Then we'll get 2 over 5. Right? And remember the length of OG there. What will be the length of AG? Will be equals to, the length of AG will be equals to 6, and that will be 2 over 5. And to get the length of EG will be equals to, we needed the length of EG there. Determine the length of EG. Right. The length of EG. Right. So the length of EG will be equals to 6 multiplied by 2 divided by 5. And the length of EG will be equals to 2,4 units. Okay. Right. So EG over OG will be 2 over 5, 2K over 5K, and the length of EG will be 2.4 units. All right. Now, in this question here, very nice question also. In this diagram, AGB are points DE on DE of triangle DEF. Now, triangle DEF, that's the triangle that we're talking about. BC, it's parallel to triangle EC. Nice one. All right. So in which triangle you'll be using there? You'll be using triangle BE that. Okay. Now, AC, you see AC is that line. It's parallel to that line. In which triangle am I going to be using? Those two, I'll be using it in this triangle. Right. DA is 4, so DA is given, it's 4. BG is 3, so where's BG? BG is 3 given. BE is 6, so that is given. CF is 8, so that is also given. Calculate with resins the length of GC. So where's GC? So GC is this part here. Okay. So in which triangle am I going to be working with? Triangle GEF. So in triangle GEF, because I'm looking for GC, I'll use GC over CF will be equals to, so I'm saying GC over CF will be equals to BG over B. Is it BE? BE, yes. BE. Now, let's substitute. GC, we don't have. CF, I have 8 units. BG, I have 3 units. BF, I have 6. BE, sorry, I have 6 units. So GC will be equals to 3 times 8 is 24 divided by 6, and that will be 4 units. So now I know that this side there is 4 units. So 4 over 8 is the same as 3 over 6. I think that will be correct. Okay, right. Calculate with resins the length of, I know what is GC, the GC is 4 now. Calculate the length of AG. How am I going to get the length of AG? So where's AG? AG is this length. Can you see this length here? It's in this triangle here. Do I have parallel lines? Yes, I do. Nice. So if I need GA, I'll say, okay, AG over this side here, over AD, will be the same as, remember it's this triangle here, we've got a 4 and an 8. So I'm going to say this will be the same as 4 over 8. But I have AD, so I'll say AG over, what is AD? It's 4. So that's 4 over 8. So AG, remember we must always write down the reasons. Ne? The reason will be line parallel to one side of a triangle, to one side of a triangle, one side. And in which triangle am I using this ratio? In triangle GDF, and therefore AC is parallel to DF. Right. So AG will be 4 times 4 when I cross multiply divided by 8. And then 16 divided by 8 is 2 units. So therefore that will be 2 units. Okay. So therefore I know that this is 2 units. And the triangle that I've used is triangle GDF. Okay. C states that write down the value of AB over DE. So now I need AB. I know that this is 2 units. This is 4 units. So we need AB over DE. Right. So which means that my AB will be 2 plus 3. So AB is going to be 2 plus 3, which is 5, over DE, which will be 4 plus 2, which is 6, plus 9. There's 4 plus 2, 6 is 9, that will be 15. So the 6, 3 is 9, 10, 11, and that will be 15. So therefore this one will be 1 over 3. Right. Okay. The next activity is still on the ratio and proportion. In the diagram, given triangle ABC, so you see, I like it when they have more than one set of parallel lines, but in this case, you only have one set. But we've got so many lines here, and these lines are the ones that are a bit confusing. But please make sure that you understand what you are doing. So you can see in this triangle here, I'm going to use triangle AGB because this is the triangle that has got two parallel lines. Né? Right, so that line is not extended, so I cannot use that triangle for ratios. Okay, right, now, H is the point on AB such that AD and HC intersected G. And they said D is the midpoint of BC. Very, very, very important. D is the midpoint of BC, meaning that this line here will be the same as that line there. So whatever length I have for BD will be the same length as for DC. Right. AB is parallel to FG. That I've already confirmed that. So AG, let's go. AG and then AD. Right. Now, obviously, then I can see that the whole length here is 3K. This small length here is 2, it's K, which means that that length there will be 2K. All right? So that then the whole length there will be 3K. All right, the ratio of that length will be 3K. Now, the first question says, let's get the ratio of BF over FG. Now, if I look at this length here is K, so BF will be K, and the length of this FG will be 2K, which means that the length of that will be K over 2K, which is the same as 1 over 2. All right. Okay, so now I can be able to play around with it because remember I'm working on this triangle here. I'm working in this triangle there, that triangle there. Sorry, this triangle here. These two lines are parallel, so I'm working in this triangle there. Because that line here is parallel to that line. Okay. Right, so now, the next question here wants us to get CG. Where's CG? So remember this line we said is the same as that line. There is a K, this is 2K, that whole length there is 3K, that one is K, and then that one we have 2K. Right. Now let's want to find the length of CG. So now, remember if this one is 3, that length also will be 3. Right? Because those two, D is the midpoint of it. So now I need to find CG. Right, CG, I need to find the length of that. The ratio of that, sorry, the ratio. CG over CH. Right. If we look at CG here, in this whole triangle here, CG will be the same as the whole length here. So CG over CH. Right. So here we know this one, this length here will be K also. So now, this whole length here and that one will be the same as that whole length here and this one. Sorry, and this one. Right. Right. So CF, so I can write CG over CH. I'm working in this whole triangle there. CG over CH will be the same as CF over BC. Then we must write this down. So CF is 5. This whole length here of BC, it will be 3 plus 2 plus 1. So which is going to be 6. So meaning that CG over CH will be 5 over 6. You can write as 5K over 6, which will give us 5 over 6. Same thing as that. All right? It is very, very, very important that you understand which triangle you are working with, because the ratios, these ratios that we're putting in there must be in the same proportion. So it must be in the same proportion. So the whole length of that is 3, and that will be 3 over 1, and that one will be 3. If it's 3 plus 2, which is 5, plus 1, which is 6. So that's why we get the length of 6 for the whole of BC. But for the length of FC, it will be 3 plus 2, which is 5. That's why we get the 5 and the 6. Okay. We're going to quickly take a 2-minute break, then we'll be back. Okay, welcome back. But I just put in the reminder there for the midpoint theorem, which you've done in grade 10. That states that, so that then we don't confuse it also with the proportionality theorem. Remember, in the midpoint theorem, these 2 points here are joining the midpoint of those lines. So those are the midpoint. The line joining the midpoints of two sides is parallel. So in other words, this line here is also parallel to the third side, and it's 1/2 the length. So in other words, your DE will be half of that. Please do not confuse it with the proportionality theorem. The proportionality theorem says that this side over there is the same as this over there. But in this case here, this side over there is going to be 1. This side over there will still be 1. Okay, so please don't confuse it with that. And this line here will be half of that line. So meaning that if this line is 5, that line will be 10. Okay, it will be doubled it. So if AD equals to DB and AE equals to EC, therefore these two lines are going to be parallel. So if this side is 5, that side is 5, this side is 3, and that side will be 3. So therefore, you can see that this line is equal to that line here equals to that. So that gives us the midpoint theorem. Don't confuse it with the proportionality theorem, please. Right. Let's look at this activity here. Very simple activity here. So in triangle ABC, we have triangle ABC. Then we have PQ, it's 7 units. Determine the length of X. That's a very easy one. So we're given that these two points are midpoints because that and that are equal. These two are equal. If we can, let's check. It will mean that this line here will be parallel to that. Okay, because those are the midpoints of that line. So how do I calculate the value of that? We said PQ will be PQ will be half of AC. All right. So if PQ is 7 units, half of AC, AC there is X. So there will be half of X equals to 7. We need the value of X here. So the 7 times 2 is 14 units. Okay. With reason that is that's the midpoint theorem. Midpoint theorem. That's what you write. Okay. That's an easier one. So I just wanted to show you that when you do proportionality, sometimes we find that there's a question that it's based on the midpoint theorem. So you just need to find out. So the confusion there comes when we have something like this and this length is given as 3 and that one is 2 and that one is 1, for instance. This one is 4 and that one is maybe 2. Then from there, the 3 and that, and this line is parallel to that. This value can never be equals to 6. The length of that line can never be equals to 6. It is because this side and that side are not equal, and this side and that side are not equal. So therefore, it cannot be a midpoint theorem. Okay, please make note of that. Right. Similarity. Remember, in similarity, we need 2 triangles. We compare 2 triangles. Yes. Same applies to congruency. We compare 2 triangles. In this case here, we said the condition for the triangles to be similar, it is because they must be equiangular triangles. So meaning that this angle here in triangle number 1 must be the same as that angle in triangle number 2. This angle here in triangle number 1 must be the same as this angle in triangle number 2. Obviously, this angle here will be equal to that angle there. I say obviously because it is called a third angle, sum of angles in a triangle. Right. So when 2 corresponding angles are equal, the third angle is automatically equal. Right? So which means that this one is automatically equal to that if these 2 are equal. Makes sense? Right. Let's check the next one. The next one says, if the sides, the ratios of the pairs of the 3 corresponding sides are in the same proportion to each other, therefore we say the 2 triangles are similar. The sign for similarity is that all 3 pairs of corresponding sides are in the same proportion, which means if I take AB, remember this is triangle ABC. This is triangle, we can call it triangle DEF. Right. AB over DE, which is 5/10, gives us a half. And then BC over EF, BC, it's 10. Over EF, it's 20. Therefore, it gives us a half. Then the last one will be AC over DF. So that will be these two, and it gives us a half. So the ratios, they are in the same proportion. It gives us a half, right? So we then say triangle ABC, it's similar to triangle DEF. The reason there is no longer equiangular, it's sides in the same proportion. Okay, right. So that should also be one of the conditions for similarity, right? When you show that it is those two are similar. In the last one, ratios of two corresponding sides are equal. In other words, AC over DF is the same as AB over DE. So those two are equal, but now here's the third one. The third one, angle A must be equal to angle D. So the angle that is inside those two lines that are in the same proportion must be equal, so that this over that must come in. Okay, so we say it's two sides in proportion and included angle. Included meaning that it is the sine, is the angle that is between the two sides that are in the same proportion. Okay. Right. Now let's quickly check similarity. Are these two triangles similar? We need to check if those two triangles are similar. But then we can check it this way. Now I have, which one is the longest side? The longest side of this triangle is that. Which one is the longest side? The longest side of this triangle is that one. If I check these two sides, let me check that, those two. They're angles. The angles is 100, and the angle to that is 100. So meaning that I'm going to just say this is this angle here, it's equals to that angle there. Which one is the smallest side? The smallest side is that angle here, right? I mean, the smallest angle is that one. The smallest side meaning that it will be that. Now let's check here. The smallest angle is this one here, and the smallest side is that side there. So I can use equiangular, or I can use sides in the same proportion. So I'm just checking this. Then we have angle 50 there and angle 50 there. We have it as a 6 there. We have it as a 12 there. All right. I can quickly check. So this side, the biggest angle is opposite 7.71. So I can say 7.71 divided by, the biggest angle is 100 here, so it's opposite that. So I can say divide by 15.42 must be equals to, the smallest angle is 30, its side is 3.92. The smallest angle is 30, its opposite 7.84. The final one, there will be 6 and 12. So if I check this, I'm using the proportion, I'm not using the angles here, because the angles I can see we've got same angles in there. But now I must also check the proportion. So if I check 7.71, and I divide this by 15.42, and the answer will be a half. If I check 3.92 and I divide this by 7.84, the answer is wrong. Yeah. And this one obviously is a half. So they are in the same proportion. Same proportion. Therefore, I can then declare that the two angles, let's call this angles the triangle DEF and triangle ABC. The two triangles are going to be similar. So I'll write triangle DEF. It's similar to triangle. Now I must check the order. So the D is 50. That side, the one that is 50, it's C. The E is 30. So which one is 30 there? It's A. And the other one is obvious. Correct? So that I then, when I do my proportion, then the proportion is correct. You see, DE over AC. DE is 7.71 over AC, which is 15.42. So the proportion must be the same. I cannot write triangle ABC in there because otherwise then the ratio will not be the same. You see, angle D equals to angle C, angle E is equals to angle A, and angle F equals to angle B. Right. Okay. Explain why triangles ABE and ACD are similar. Now, we want to explain why this triangle ABE and triangle ACD, the smaller triangle and the bigger triangle. Now, if these two angles are equal, what can we say? This line here will be parallel to this line there. Okay, because they are corresponding angles. Right. Angle A is common in this triangle. Now, I'm going to call this angle E1. Right. So, how do we know that these two triangles will be similar? The first thing here, angle B, I'm going to call it angle ABE. Angle ABE is equals to angle ACD in the other triangle. So in other words, this angle is 112, this angle is 112. Right. This angle is a common angle. So the second thing there is that A is a common angle. There's angle A there, there's angle A there. Angle A there and angle A there. Angle B there is equals to angle D. So what can we say? The last one, remember the last one will be sum of angles in a triangle, or the third angle. So the third angle will be E1 on this side will be equals to angle D. So can you see? Therefore, I can then say these two triangles are similar. Triangle ABE is similar to triangle ACD. I'm going to write them this way. The A is common angle. Angle B and angle C are equal. And angle E and D are, they're also equal anyway because of this line being parallel to that. Okay, so that's why these two triangles are going to be similar because of those three. So what do we write to explain why? It's angle, angle, angle. All right, we're not going to use any ratios there for this. Okay, find the length of AD. The length of AD. Now, how am I going to find the length of AD here? So I can use, remember, if the two triangles are similar, we said triangle ABE. ABE, it's similar to triangle we said ABE, so it's ACD. Right. I can make a ratio here. AB over AC, it's equals to AE over AD. That will also be equals to BE over CD. There's no length that I'm looking for in these ratios here. But I know that if I'm looking for AD, what can I use? I can use this ratio here. So I can use that ratio over that. It's equals to this ratio here over this. I can use that. Right. So in this triangle here, I can use the whole of that over this and this over that. So now, how am I going to use that? So I'm going to say AE over AD will be the same as EB over CD, right? So what is AE here? It's 7. What is AD? That's what I don't know. Right, what is EB? EB will be 2. And what is BC there? It's going to be 5. So AD will be equals to 7 times 5 all over 2. And then AD will be, I think, 17,5 centimeters. Right? Okay, so in this ratio, I can be able to use those ratios. I can use that ratio over there equals to this over that in any triangle. Okay, right. Now, the length of DE, there. So now I don't have the length of DE here. So now let's get the length of DE. How am I going to get DE? So if I use the ratio DE over AD, so AD I already have it as 17,5, right? So now I need the length of AD, right? So the length of AD will be, sorry, I need the length of DE, not AD. So DE over AD, so if I use that length, it will be 2, what is DE there? DE we do not have. So in this case, for me to get the length of AD, let me just quickly check. So we've got DE, the whole length there we have. So this length there we do not have. So I can also use this length again here and that length there. So I can say DE over this length will be the same as this length over that length. So I can say DE here over AD will be the same as this length here over that length. Right. So now I know what is AD. My AD will be DE, it's going to be AD, it's 17,5 equals to 2 over 5. So that one will be 35 all over 5 for DE. So my DE will be equals to 7 units. I think it's in centimeters. Yes, it's in centimeters. So I can have the D as 7 centimeters. Okay, right. Now, determine the length of BC. In this case, how am I going to get the length of BC? Now I know that one is 7. And if this is this over that, it's 1. Obviously, this over that will also be 1. So the length of that will be 6. You can calculate it there. You can calculate it by using AE over DE is the same as AB over BC. Then we know we have 7 over 7 equals to AB, which is 6 over BC, and BC will still be 6 units, 6 centimeters. Okay, that's quite easy. All right, the last part 1 activity, we're given triangle AED with points C and B on AE and BD. Now we need to find the lengths, the sizes of those two with results. First of all, the angle here that we're going to get there will be it will be 180 degrees. Can start with the x. So the x angle will be equals to 180 degrees minus, remember I'm working now in the bigger triangle, 78 degrees minus 69 degrees. So that will be 180 minus 78 degrees minus 69 degrees. And the angle that I'm going to get there will be 33 degrees. If this angle here is 33 degrees, I can now get that one. Because that angle here will be 180 degrees in a smaller triangle, minus 78, minus 33, and this gives me 69 degrees. What do I know? I was never told that BC and ED are parallel. So what do I know now? I now know that that line and that line will be parallel. This angle and that angle are alternating. This angle and that angle are sorry, corresponding, not alternating, corresponding. So now I have the x value and I've got the y value. The y value is 69 degrees, and those two angles, I then get them. Okay, right. In B, it states that show that ABC is similar to ADE. This is 69, that is 33. And I think that's quite straightforward. Angle A is common, 78 degrees. That's the first thing here. The second thing here is that angle C and angle E are equal. So I'm going to call it angle ABC. It's equals to angle ADE. And they're both equals to 69. ABC and ADE, they're both equals to 69. And obvious, the third one is obvious. So it will be angle AED equals to angle AED equals to angle ACB. And they're both equal to 33 degrees. So therefore, if I see that the three angles are equal, three sets of angles are equal, therefore, triangle ABC is similar to triangle ADE. Right? Triangle. Right. And the reason will be angle. Okay. Right. Activity 12, very nice activity, an exam question here. Easy exam question here. Immediately I can see if this is a cyclic quad, if this is a cyclic quad here. I already know the properties of a cyclic quad there. Opposite angles are equal. It equals to 180 degrees. The sum of opposite angles are equals to 180. Exterior angle of a cyclic quad, so I have an idea if I have got cyclic quads. PK, that line here is a tangent. I know the angle between the tangent and the chord, right? And then this line here is parallel to that line, then it must form some corresponding angles or alternating angles there. It says determine with resonance another two angles equals to 36. When given that this is 57, that is 36. Let's check quickly. So this angle here is between the tangent and the chord, meaning that L1 will be 36 degrees. L1 will be equals to 36 degrees. The reason will be angle between the tangent and the chord. We call it a tan-chord theorem, all right? The next one here, if I check this line is parallel to that and that line is parallel to that, so therefore the N will be 36. So angle N will also be 36 degrees. The reason will be alternate angles. Parallel lines, you must write them down. KP is parallel to LN. Very, very important. Right. In the next one, there's I get the size of K2. I know that this is 36. Oh, no, yes, that is 36. I've got 57. That's an easier one to get. K2 will be 180 degrees minus 57 degrees minus 36 degrees. And that angle that I'm going to get there will be 87 degrees. Right. Okay. And in the last question there, show that triangle KLS, this triangle here, which has got 87 there and it's got 36 there. Right. It's similar to MNS. MNS. So I'm just going to shade this one here. I know that this is 36 degrees. Right. Now, this angle here, I know that angle. It's an exterior angle of a cyclic quad. You see, they didn't just tell you that it's a cyclic quad. It's an exterior angle of a cyclic quad, which means that angle here will be the same as that angle, which is 87 degrees. All right? So how am I going to get the two triangles to be similar? First thing here is, in triangle KLMS, K will be equal to M2. Angle K2 equals to angle M2. So what do I say? Exterior angle of a cyclic quad. Okay, right? Okay, second thing, angle L1 in this triangle, it's equals to angle N. We have already proved that angle L1 equals to angle N. They are both equals to 36 degrees. Not 360, but 36 degrees. And I can just say this one is proved. Because I've already got that one. All right? The third one is obvious. That S3 must be equals to S1. So S1 equals to S3. You can write third angle or sum of angles in a triangle. Therefore, if I've got three things to be equal, then I can say KLS, it's similar to triangle M and S. Those two are similar because of angle. So if it's angle, this angle here, meaning that angle here will be 57 degrees. So if that angle is 57 degrees, that angle is 57, this is 87, 87, 36, 36. Similar triangles, equiangular triangles, because the angles in there are equal. You can see the K and the M, the L and the N, the S and the S. So it will be S1 and S3 on the other triangle. If the two triangles are similar, then we know that shown that those two. Remember, in technical maths, you're only going to get the angles given there, or some of them are equal because of the theorem. So not always you're going to get the values of those angles, but some of angles will be equal because of the theorems that we have done in the previous grades. And let me take this opportunity to give you the general hints when solving these writers. You must read the statement. Sometimes the statement is hidden there. It's hidden in the words there. And then you need to read the given statement twice. Ensure that all the given information is indicated on the diagram. This is also very, very, very important. Analyze and note down all the theorems appearing in the diagram. Use different colors to mark off equal angles and sides. Start from the given angle to track the solution. Okay. And after calculating any angle, put the information on the diagram, because then it assists you in terms of getting the other angles in that sketch. The next lesson will be paper 1 revision, as that will be the end of our the term 2 ATP. So then we have to do revision. So the next one, it will be paper 1 revision. Thank you so much and wishing you all the best in the exams that you are writing. Please practice and then you'll get these things right. Thank you.